Good afternoon, all of you. My name is Mayuri Jagannath Phadatare, currently working as Assistant Professor, Department of Statistics. Today, we see the topic correlation. The first concept for correlation is important bivariate data. What is definition of bivariate data? If we consider one single variable, for example, number of students in a class is called univariate data. If we have considered two variables, height and weight of a person is called a bivariate data. Then definition of correlation. A linear relationship between two variables x and y which measures the strength, degree and direction of that two variables is called a correlation. It is denoted by small r and it is lies between -1 to 1. Correlation. In correlation, we check the relation between two variables x and y. Next point is types of correlation. There are four types of correlation. First is positive correlation, second is negative correlation, third is perfect correlation, and fourth is no correlation. We see one by one. First is positive correlation. If the value of one variable is increases, the value of another variable is also increases. Or the value of one variable decreases, other variable also decreases. Is called a positive correlation. Means in positive correlation, two variables are changes in same direction. For example, we have considered income and expenditure of a family, or supply and demand, or price and quantities. Second type is negative correlation. If value of one variable increases, the value of another variable decreases, or vice versa. Means value of first variable decreases, second variable increases is called a negative correlation. Negative correlated variables are changes in opposite direction. For example, pressure and volume of a gas. Second example is supply and price of a commodity. When supply is increases, the price of quantities are decreases. These variables are negatively correlated. Then third type is perfect correlation. If the values of variable is changes corresponding to and proportional to each other is called a perfect correlation. Fourth is no correlation. No correlation means value of one variable increases or decreases, the value of another variable remains constant, does not affect on another variable, is called a no relation, and these two variables are called a uncorrelated variables. We discuss all four parts of correlation. Next point is Methods of detecting correlation. First method is scatter diagram. Second method is Carl Pearson's coefficient of skewness. And third is Spearman's rank correlation coefficient. There are three methods of detecting correlation. First is scatter diagram, second is Carl-Pearson coefficient of skewness, and third is Spearman's rank correlation coefficient. We see the first scatter diagram. Scatter diagram is a simple representation of nature of correlation. It can be used for diagrammatic representation of bivariate data. For scatter diagram, we consider two axes for variable x and y. We see different types of scatter diagram. If all points near to narrow strip in and if value of r is equal to 0.92, we consider one variable on x-axis, one variable on y-axis. There is a high degree positive correlation between these two variables. High degree positive correlation. Similarly, if r is equal to minus 0.92, there is high degree negative correlation between these two variables. Next diagram is if all points lie in straight line and value of r is equal to +1, there is perfect positive correlation between two variables. Next diagram is r is equal to -1, means these two variables are negatively correlated. There is perfect positive correlation between two variables x and y. Next, if r is equal to 0.42, there is low degree positive correlation. Similarly, if r is equal to minus 0.42, there is low degree negative correlation between these two variables x and y. And last scatter diagram, value of one variable increases, it does not affect on value of another variables, r is equal to 0, and which is called a there is no correlation between these two variables. This is first method of detecting correlation, which is scatter diagram, and we see all this scatter diagram. Second method, Karl Pearson's coefficient of skewness. Coefficients of correlation. Karl Pearson coefficient of correlation is defined as the ratio between covariance between xy and divided by product of SD of x and SD of y. It is denoted by small r, covariance between xy divided by sigma x into sigma y, where covariance between xy, which is equal to 1 upon n sum of x into y minus x bar y, and sigma x, which is SD, standard deviation of x, and sigma y, which is equal to standard deviation of y. It is denoted by r, and it is also lies between -1 to 1. Then last method, Spearman's rank correlation coefficient, which is denoted by capital R, and which is also lies between -1 to 1. Spearman's rank correlation coefficient. There are two cases. First is no ties. Then formula for Spearman's rank correlation coefficient is 1 minus 6 sum of di square divided by n into bracket n square minus 1, where di is the difference between rank for xi and rank for y, and n is the number of observations. Second case for repeated rank. The formula is r is equal to 1 minus 6 sum of di square plus tx plus ty divided by n into bracket n square minus 1, where di square is the difference between two ranks. Tx is total correction for ties in x series, and ty is the total correction for ties in y series. Today we will discuss the concept of correlation, their types and methods of detecting correlation. Thank you.